use Jefferson's method of determining apportionment. What is it? How do we use it? Jefferson starts like the other methods in that we find the standard divisor and standard quota for each state. Jefferson's method uses the lower quota. So after we find the standard quota, we're going to find the lower quota for each state, and we find the sum of those lower quotas. If it's equal to the number of desired reps, then we're done, and that's great. However, a lot of times that total will be smaller than the number of desired representatives, and therefore we must decrease the standard divisor to get a modified divisor. Once we have that modified divisor, we are going to find a new standard quota and then a new lower quota until the sum of the lower quotas equals the desired number of representatives. So let's use Jefferson's method to determine the appropriate apportionment for a desired 50 representatives. We have 3 states, West Daisy, North Rose, and East Mulch populations given. Let's start by finding the standard divisor. So I add the 3 populations together, 255,983 plus 193,048 plus 108,349 for a total population of 557,380. Now that I have that total population, I divide by my standard divisor. I divide by my desired 50 representatives to get my standard divisor of 11,147 and 6/10. Now that I have that standard divisor, I can find the standard quota for each state. So I take the population of West Daisy, 255,983, and I divide by the standard divisor of 11,147 and 6/10. West Daisy's standard quota is 22.963. I do the same thing for North Rose and East Mulch, and I find North Rose has a standard quota of 17.317, and East Mulch has a standard quota of 9.719. When I go into a table and I have my standard quotas listed for each state, I then want to find the lower quota. And remember, the lower quota is simply get rid of the decimals. So 22, 17, and 9. When I add the lower quotas to get the sum, I end up with 48. This is too few representatives, right? I need 50. And therefore, we're going to decrease the standard divisor and try the process again. So our standard divisor was 11,147 and 6/10. Let's decrease it to 11,000 and see what happens, right? Because it doesn't tell us what to decrease it to. It just says decrease. So if I decrease it to 11,000, my standard quota for West Daisy, right? Population divided by the new modified divisor gives me a standard quota of 23.271. North Rose changes to 17.549, and East Mulch changes to 9.849. My lower quotas are now 23, 17, and 9 for a total of 49. Still too low. So I needed to decrease the divisor again. So let's decrease to 10,750, right? I don't want to go too much because that, could change things. So if I change the divisor, I do it again. Population divided by my new modified divisor of 10,750. West Daisy is now 23.812. North Rose is 17.957, and East Mulch is now 10.078. So my lower quotas are 23, 17, and 10, which totals to 50. So as soon as I hit 50, I can say whoop, whoop, and I have my lower quotas, which are now the number of representatives for each state. 23 for West Daisy, 17 for North Rose, and 10 for East Mulch, using Jefferson's method.